Then we have the next principle called LSP. So LSP is nothing but Liskov substitution principle. So Liskov substitution principle is nothing but derived class object should be replaceable in the place of base class object. So we should design classes in such a way that a derived class object should be replaceable at the base class object. So an example of violating this principle is we have square. So every square is a rectangle. So consider we are like we are deriving square from rectangle base class. If so, consider rectangle is having change with change height. Then if we replace the square at the place of a rectangle object, then changing height and width is possible in the rectangle. So I am changing the width and height of the square. Width or height, any one I am changing to different value. So now if you see the area of that is not like if we calculate the area, then uh, it will be uh, calling the area of square. Area of square is nothing but a square, but here it's having two different values for width and length, so it is violating the basic property of the square. So square should have both sides equal, but here we are having two different size width and length. So if you calculate the area also, it won't be consistent. So this is wrong. We should not derive object like class like this. So you should consider writing separate square a separate class and rectangle a separate class. So this is about LSP. So here if we substitute square in place of rectangle, it will violate. So this is a LSP. And the next example is ISP. So ISP is nothing but interface segregation principle. So this is nothing but segregating the interfaces. So it states that avoid fat interfaces. So avoid fat interfaces means we should not have interfaces with a lot of functionality. So we need to segregate functionalities to separate interfaces. So if we have big interface with a lot of functionality, if we want just a small interface need to be implemented in some class, then if we implement this interface for that class, then it will since it have all the functions of mutual function, then it need to implement all functions. So but other functions are not required, since it need only small functionality of it. So what we need to do is we need to write dummy function for the unnecessary functions. So we should avoid this type of situation in our code. So instead of what we can do is we can segregate the interface into many smaller interfaces, so that we can implement that alone. So basic idea is we need to segregate the interfaces to smaller ones. So that is interface segregation principle. And finally we have DAP principle. This is dependency inversion principle. So dependency inversion principle is nothing but high level modules should not be dependent on low level modules and vice versa. So instead they should depend on the abstraction. So that means high level modules and low level modules should not be dependent on each other. So I will have the same example. So this mobile notification. Here this is a higher level module and this is lower level module. Here if you see they are tightly coupled. But here if you see notification is high level language, high level module, and iMobile app notification is low level module. So both are dependent, but these are dependent on this abstraction layer, interface layer. So in future if any new module comes also, it will fit into the same interface, new type of notification. So it is not tightly coupled with the lower level module. The higher level module is not tightly coupled with the lower level module, but here in the first example the higher level module is tightly coupled with the lower level module. So the second example, if you see, higher level module is dependent on the abstraction layer, that is nothing but the interface. So this is about uh, DIP, dependency inversion principle. So I hope you have understood about the solid principles. Thank you.